Dear students, today our topic is we will continue the halogens group 17 elements. Halogen family. So the elements of the group are fluorine, symbol is F, chlorine, bromine, iodine, and aspartame. Symbol fluorine, chlorine, bromine, iodine, and aspartame. Before discussing the trends in their properties, we divide their electronic configuration. Writing the electronic configuration of the halogens, we have to write their atomic number. So the fluorine, its atomic number is 9. Chlorine, its atomic number is, we have to add 8, 17, and bromine, we will add 18 electrons and 35. Similarly, iodine, again add 18 to 35, that is 53, and then we will add 32 to 53, it is 85. So the atomic number of the fluorine is 9, chlorine is 17, bromine is 35, iodine 53, and aspartame 85. Now we will write their electronic configuration. The electronic configuration of fluorine is 1s2, 2s2, 2p5. So the outer shell electronic configuration of these halogens is ns2, np5. So here in case of fluorine we have 2s2, 2p5, the ratio of n, that means we have second shell. In second shell, in s orbital we have 2 electrons, and in p subshell we have 5 electrons. Or we can show it in terms of the noble gases. It is helium 1s2, and it is then 2s2, 2p5. So this is the electronic configuration of the fluorine. Now chlorine is 1s2, 2s2, 2p6, 3s2, 3p5. And again, in terms of the noble gases, it is helium neon, whose atomic number is 10. So 10, then 3s2, 3p5. In terms of bromine, we write 1s2, 2s2, 2p6, 3s2, 3p6, we have 3d10, 4s2, 4p5. Again we have bromine से पहले जो है the atom which has the noble gas is helium neon is argon, whose atomic number is 18. So 18 यहाँ से शुरू होके 2, 4, 10, 12 is 18, then we have 3d10, क्योंकि 18 जो है वो R1 का इलेक्ट्रॉनिक कंफिग्रेशन है, then we have 3d10, 4s2, 4p5. So the outer electronic shell configuration is 4s2, 4p5. Now, iodine, its atomic number is 53 and the electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6, 4d10, 5s2, 5p5. We count the number of electrons, that is 2, 4, 10, 12, 18, 28, 30, 36. That is when it is 36, the electronic configuration helium 2, 10, 18, 36, that is krypton. Then we have 4d10, 36, 46, 5s2, 48, 48 and 5, 53, 5, 5. So again the outermost electronic shell electronic configuration is 5s2, 5p5. Now we have the last, that is S13, and the electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6, 4d10, 4f14. There F subshell electrons also filled in the f orbital of the F subshell. 4f14, 5s2, 5p6, 5d10, then we have 6s2, 6p5. Electrons in the F subshell of the F orbitals of the F subshell also only take place in the S13. So we will count the number of the electrons. First we must get 85 electrons, 2, 4, 10, 18, 18 or 6, 24, 32, 4, 10, 12, 18, 28, 30, 36, 46, 46 plus 14, 48, 60, 62, 66, 62, 68, 78, 80 and 85. Now, before this S13, we have xenon, and its electronic configuration is 54. So 2, 4, 10, 12, 18, 28, 30, 36, 46, 46 and 46 यहाँ तक. इसके बाद 48, 48 and 6 हो गई 54. ये 4f13 जो है, इससे पहले ये फिल अप होते हैं. अभी मैं वो दिखाऊं. Before 4f, 5s and 5p get filled, तो 54 यहाँ तक आते हैं. बाकी जो बचते हैं, that is 4f14, 5d10, 6s2, 6p5. This is the electronic configuration of astatine. We have xenon 54, 68, 78, 80 and 85. Now the question arises, why 5s and 5p, which according to the, अगर आप देखोगे 4f पहले आता है 5s सीक्वेंस के हिसाब से, लेकिन according to the increasing energy of the orbitals 4f की एनर्जी जो है वो ज्यादा है instead of 5s and 5p. So actually you have read in the 11th class while orbital the filling of the electrons, then understood 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f, 5s, 5p, 5d, 5f, 6s, 6p. While filling the electrons, according to the increasing energy of the orbitals, n plus r will apply होगी. ये हम increasing order of the orbitals देखते हैं according to the increasing order of the energy. तो पहले 1s, उसके बाद 2s, उसके बाद यहाँ जाना है 2p, 3s, 2p, 3s, इसके बाद 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, 4f, then 5d, 6p, this is the increasing order of the energy of the orbitals. तो 4d के बाद we have filled 4d completely, 10 electrons in the 4d. इसके बाद 5s, after 4d, 4p के बाद 5s, फिर 4d, 4s, 4p, 4d, 5s, 5p. तो 5p तक जो है we have filled the electrons. तो आप देख लीजिए वहां तक 14 आता है and 4f14 इसकी एनर्जी उसके बाद आती है. तो यहाँ तक फिर हमने क्यों लिखा, क्योंकि यहाँ तक ये ऑर्बिटल्स completely original, they are completely filled and then we arrange them according to their sequence energy. ये सीक्वेंस के हिसाब से फर्स्ट शेल, सेकंड शेल, थर्ड शेल, तो उस हिसाब से हम लिखते हैं पहले 3s, 3p, 3d, 4s, 4p, 4d. इसके बाद 4f14 जो है इसकी एनर्जी जो है वो ज्यादा है, इसीलिए यहाँ तक 54, क्योंकि ये सारी कंप्लीटली फिल्ड है तो हम इनको इंक्रीजिंग ऑर्डर ऑफ द शेल्स देते हैं, सीक्वेंस बनाते हैं ताकि इनको याद करना आसान हो जाए. उसके बाद 54 जब आ गई है, इसके बाद 4f14 में हमने कितने बार किए, 14 बार किए. पहले 6s में 2 बारने हैं, फिर 4f में 14 बारने हैं, फिर 5d में 10 बारने हैं, लास्ट में 6p में 5 बारने हैं. तो इस 5 बारने 6 इंस्टेड ऑफ 6 हम 5 बारते हैं तो 85 आते हैं. अब यहाँ तक हमें xenon आ गया, तो ये भी हमने ऑर्डर में लिखे, पहले 4f लिखा, फिर 5d लिखा, उसके बाद 6s लिखा एंड 6p, 4f, 5d, 6s and 6p. So this was the electronic configuration of these halogens. इसके बाद we will discuss the trends in their properties तो एक एक करके हम उनकी प्रॉपर्टीज पहले दिखाएंगे। Transmedia properties. Transmedia properties. Now, question here: atomic and ionic radii. Number second, melting and boiling points. Number third, ionization enthalpy. Number four, electron gain enthalpy. Number five, electronegativity. Then we will discuss oxidation state. Again, we will write these halogens: fluorine, chlorine, bromine, iodine, etc. 9, 17, 35, 53, and 85. Atomic number. Group 17 elements, this is down the group, we write them. Atomic and ionic radii. ये जो atomic and ionic radii है, these halogens have the smallest atomic radii in their respective periods as compared to the other elements of in their period. For example, we have fluorine जो है ये 9 है, पहले पीरियड में हमें हाइड्रोजन, हीलियम आता है, इसके बाद लिथियम 3, सोडियम 11, तो लिथियम के बाद बोरान 4, बेरिलियम 4, बोरान 5, कार्बन 6, nitrogen 7, oxygen 8, fluorine 9, and we have then neon 10. These are the second period elements. As we move across the period, the atomic size decreases and the nuclear charge increases. So यहाँ तक जो है the fluorine अगर हम लेंगे, the fluorine has the smallest atomic radii as compared to other elements in their period. तो second period में fluorine का atomic radii जो है size जो है वो सबसे छोटा है, क्योंकि as we move across the period the atomic size decreases and the nuclear charge increases. इसी तरह से अगर हम क्लोरीन ले लेंगे तो अपने पीरियड में क्लोरीन का एटॉमिक रेडियस जो है वो स्मॉलेस्ट है. सो बट दिस एटॉमिक रेडियस as well as the ionic radii, it increases down the group because the number of shells increase with the increase of the elements as we move down the group. So फ्लोरीन इसका एटॉमिक रेडियस एज वेल एज द आयोनिक रेडियस सबसे कम है इफ यू कंपेयर विद फ्लोरीन, क्लोरीन, आयोडीन एंड एसिड। सिमिलरली इसके बाद क्लोरीन, ब्रोमीन और एटॉमिक रेडियस जो है एज वेल एज द आयोनिक रेडियस दैट इंक्रीजेस डाउन द ग्रुप बिकॉज अगर इसमें 2 शेल है, इसमें 3 है, द नंबर ऑफ शेल्स और इन अदर वर्ड्स द एटॉमिक नंबर और द एटॉमिक साइज गो ऑन increasing as we move down the group. So melting and boiling points. As we move down the group, their melting as well as the boiling points increase because their atomic number increases down the group, or we can say this melting as well as boiling point is due to the ये जो इनमें फोर्स ऑफ इंटरमॉलिक्यूलर फोर्स ऑफ अट्रैक्शन है वो इंक्रीज होता है डाउन द ग्रुप। दिस इज व्हाई दे आर मेल्टिंग एज वेल एज द बॉइलिंग पॉइंट इंक्रीज डाउन द ग्रुप। आयनाइजेशन एंथैल्पी। Ionization enthalpy means the amount of energy required to remove the most loosely bound electron. क्योंकि ये जो we cannot remove the electron from these इनकी जो हैं वो आयनाइजेशन एंथैल्पी इनकी बहुत हाई है क्योंकि इन्हें एक इलेक्ट्रॉन चाहिए to attain the stable configuration. So they accept the electron instead to lose the electron. This is why their ionization enthalpy is very high क्योंकि हमें ज़्यादा एनर्जी देनी पड़ती है to remove the electron from their outermost shell. But this ionization enthalpy decreases as we move down the group because the atomic size increases or the atomic radius increases. Now, electron gain enthalpy. अगर हम देखेंगे ग्रुप 17 के बाद ग्रुप 18 है तो ग्रुप 18 के एलिमेंट्स है हीलियम, नियॉन, आर्गन, क्रिप्टॉन, ज़ेनॉन, रेडॉन। तो इसका एटॉमिक नंबर 2 है, इसका एटॉमिक नंबर 10 है। वी हैव फ्लोरीन 9, वी हैव फ्लोरीन 17 एंड argon is 18. We have bromine, it is 35, it is 36. So as we move down the group, we can see कि हर एक एलिमेंट हेलोजन को इन देयर रेस्पेक्टिव पीरियड्स उनका एक इलेक्ट्रॉन कम है फ्रॉम देयर नियरेस्ट नोबल गैसेस। सो दे हैव ग्रेट टेंडेंसी टू एक्सेप्ट द इलेक्ट्रॉन, दे हैव ग्रेट टेंडेंसी टू accept the electron so that their electronic configuration will become equal to the noble gas configuration so that they will attain the stable noble gas configuration. So their electron gain enthalpy is very high. Yani कि their negative value of the electron negative, they have a large negative electron gain enthalpy which decreases down the group. लेकिन इसमें एक चीज है, फ्लोरीन has lesser electron gain enthalpy than chlorine. क्योंकि electron gain enthalpy means कि जब हम इलेक्ट्रॉन इनको देते हैं, they accept the electron, वो कितनी एनर्जी लूज करते हैं। तो जब हम फ्लोरीन को इलेक्ट्रॉन देते हैं, it loses. यहाँ पर क्लोरीन हैज द हाईएस्ट नेगेटिव इलेक्ट्रॉन गेन एंथैल्पी एज कंपेयर्ड टू द अदर एलिमेंट्स ऑफ द ग्रुप। तो ये ट्रेंड में फ्लोरीन की कम क्यों है क्लोरीन से? क्योंकि जो ही हम इलेक्ट्रॉन देते हैं, बिकॉज ऑफ द स्मॉलर साइज ऑफ द फ्लोरीन देयर एक्सिस्ट्स इलेक्ट्रॉन रिपल्शन। सो द इनकमिंग इलेक्ट्रॉन विल नॉट enjoy the attraction by the nucleus because of the smaller size of the fluorine atom. So the electron gain enthalpy, chlorine has the highest, it has highest negative electron gain enthalpy, and the electron gain enthalpy decreases down the group as the size of the atom from chlorine to iodine. From chlorine to iodine, because astatine is a radioactive element. Now, electronegativity, because of the smaller size of these halogens and because of their greater nuclear charge in their respective periods, they have highest value of electronegativity, and fluorine has the highest electronegativity value. Its value is 4.0. The electronegativity value decreases down the group. So, why they have the highest value of the electronegativity? It is because of their smaller size and higher nuclear charge. Oxidation state. Halogens have one electron less than their nearest noble gas configuration. So, they accept this, they have the highest tendency, higher tendency to accept the electron, and it accepts this electron by attracting the electron or by sharing the electron. Therefore, they exhibit either -1 oxidation state or positive oxidation state. But fluorine is the most electronegative element, therefore it always exists in only -1 oxidation state. Whereas the other elements of the group, in addition to the minus oxidation state, they do exist in +1, +3, +5 and +7 oxidation states as well. This is because fluorine do not possess the vacant d orbitals, whereas the other elements like chlorine, bromine, iodine, they do possess the vacant d orbitals, and their +3, +5 and +7 oxidation state is due to the shifting of the electron from the s and p orbitals. The electrons from their outer shell s and p electrons get excited to the next higher d orbital, due to which they exhibit +3, +5 and +7 oxidation state. So, in addition to the -1 oxidation state, the other elements of the group, the halogen elements like chlorine, bromine and iodine, do exhibit +3, +5 and +7 oxidation state as well. Iodine and fluorine, being the most electronegative element, exhibit only -1 oxidation state. So this is about terms in their properties and the oxidation state.